All right, number 5. A farmer with 12,000 feet of fencing wants to enclose. Okay, actually, the 12,000 feet of fencing, that's probably the constraint. The reason I think that is because they only have 12,000 feet of fencing to work with. That's all that is there. And that's the thing that is holding them back. So that's probably the thing. So 12,000 feet of fencing. And fencing is kind of a perimeter. So I'm going to guess, this is just a guess at the moment. A farmer with 12,000 feet of fencing wants to enclose a rectangular plot that borders a straight river. Okay, so borders a straight river. And by the way, I put my river on the right side, but you could put it anywhere else. I just put it there. If the farmer does not fence along the river, what is the largest area that can be enclosed? Okay, so everywhere else is being fenced. And it wants the largest area. So objective is maximize area. Okay, so let's label some things. If this is the length, then this up here is also the length, and this we'll call W. Okay, so I need something for area. Area would be equal to the width times the length. That's two variables though, so that's not going to work. So I'll go to my constraint equation and see if I can work that out. So the perimeter, I only have 12,000 feet of fencing. So that would be L plus W plus L again, or 2LW, 2L plus W. And so that's the length of fence I need, and I know that's 12,000. So I will get W by itself and then plug it into my area equation. W equals 12,000 minus 2L. That I will plug into my area. Area equals 12,000 minus 2L times L, or 12,000 minus 2L squared. All right, I'll take the derivative because I want the critical point of the area. Derivative of 12,000 is 0. Get minus 4. And then L to the first power. Okay. I was really confused because if that's my derivative, there's a real problem here. So actually, I think I missed something. When I multiplied 12,000 times L, I forgot to put an L here. My bad. Okay, so that changes things a little bit. I want the derivative. The derivative should be, let's see, 12,000. That is going to help a lot. Sorry about all this stuff coming up on my laptop. Oh, you might not be able to see it. You can probably just hear it. Oh well. Derivative of 2L squared is minus 4L. So I've got a derivative. I'll set it equal to 0. Add 4L. Divide by 4. Okay, I think that's 3,000. I think L equals 3,000. So I think that's my final answer, but I should check to make sure there isn't like more directions here. What is the largest area that can be enclosed? Okay, what is the area? So I think When I wrote this problem, I was maybe tired or something because it says, what is the largest area that can be enclosed? What is the area? That's the same question twice. So I actually wasn't done. I need to find the area, which means I also need to figure out what W is. And we found that W was equal to 12,000 minus 2 times L, which is 3,000. So that's 12,000 minus 6,000, or just regular 6,000. And then to find the area is going to equal 3,000 times 6,000. And I am pretty garbage at mental math, but I think that's 18 something. Let's get this right. So 3,000 times 6,000. Yep, 18 and then 6 zeros. And that's feet squared. Cool. You might be asking yourself, like, why didn't you check to make sure that your critical point really was what you wanted it to be? So I'm looking to find the largest possible area. So I wanted to make sure it was a maximum, except that I already know that a quadratic, which is what we had, a quadratic, it either faces up or it faces down, and so I'm not worried in this case. Okay. If you have any questions, post them on the discussion board. Oh, actually, this is important. I am not going to do this problem after all. This, it's not a great problem, so you can ignore that one. Okay, see you later.